That one's got it.
We're definitely giving points for originality of design, that's for sure. You can clearly see that these members here are redundant. Okay? So let's keep tension that up, okay? What I don't understand, okay, well, let's think about this, ladies and gentlemen. Which way is that deck going to want to go? Down. So it's going to be an arch in this direction. Therefore, what should these be to help reinforce that? They'll be in compression. Do you understand? As that does an arch like this, it's going to want to lift the ends up, which they're already going to start to do. Here. Get rid of that unique quote-unquote design feature. So you have to ask yourself the question, as architects, what's the function of a bridge? Is it to look good or is it to stand up? Both. Okay. What if that problem that makes it look interesting is structurally redundant? As you as a designer, would you still want to do that? Or would you have an issue with that? So you're saying to me that beauty, or something that looks good, is intrinsically related to function. Is that correct? Right now, that top, those three tension beams, that whole structure on the top of that deck is a wonderful circular decoration.
No, things are like
So as we see, I can almost guarantee that as we load this next brick up, who thinks that these cables, yeah, look at them right now. Keep going. Don't mind me. They're not going to go into compression. Tension, sorry. That's still completely redundant. Keep loading. What I would do now, to get here, well, I'll load the next brick and then we'll split just as a two. It's a well-designed loading system. Okay? Jay's got the cables equally distributed right away across the deck of the bridge. Okay? Now, what's that deck doing right now? What's the shape of it? It's going like that. And as it goes down more and more, it's going to do that. It's going to want to go sag down, 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 which is going to make these forces inside here go up, 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 and that way these are going to get more and more and more and more redundant. To the point where I'll just get the scissors out. So let's get the bricks now side by side. Okay? And how much does this bridge weigh? It looks quite heavy. 70 grams. Now, if we get rid of all of this, it's going to weigh a lot less. Did you weigh it with without the support of the column, right? Without it. So let's put the bricks side by side. It's not going to go anywhere. We know it's going to take at least 6 bricks and stack them up pretty quick. That's it. Anyone wants to put holes in it to grab? Here. Next one.
We can make that amazing.
Okay, now look at the ends here. Here we go. You see that? You see how that's blowing up? These strings are becoming ever more redundant. Should we get rid of them now? What? Yeah? Oh, what was that? So this is completely redundant. Okay? It's not doing anything. Oh.
Yeah.
Oops. Oh, is this a moment of embarrassment? Did it do something?
It must have. It did.
Well, you better make a note of that. How could that be? No, it's okay. How could that be? It was at 6 bricks already, so you don't want to overload it. Okay? How could that be? If they were completely in slack, how did cutting them? That's the learning. Okay? How did cutting tension members, which were not in tension, contribute then to the failure of the bridge? What do you think? How is that possible? Are you still recuperating? Sorry about that. Okay, you're completely shattered. Okay, it's okay.
I think
It's really important.
They were still like, they were still useful, but it's just a strain on the thing was starting to weigh in, so it was slowly deteriorating. But I don't think.
I'd like to get the answer to that question when your design report. Okay, how did cutting of tension cables, which were not in tension, they were clearly slack, contribute to the failure of the bridge? Okay. All right. Thank you for that. Okay, let's have a look at the bridge. And where exactly did it fail? Okay. So it failed right in the middle. Yeah. Interesting. They're so slack. Comment on that though. Okay. Anyway, that's good. Thank you. Okay. Okay, folks. Let's get a structural report on that. Who's going to choose the next team? Okay. Team 19, Ivan, Corinna, and Florin. While we're getting this all set up, ladies and gentlemen, can I ask Team 10, Team 16, Team 14, and Team 4 just to write down how many bricks and what grams of bricks weighed? Again, just to repeat myself, just to fill in that information, Team 10, 16, 14, and 4, if you just fill in that information on the calendar there. Thanks. Okay, first of all, what does this bridge weigh?
62 grams. Without
62 grams. 62 grams. Without that. Okay. Okay. That's a heavy bridge. Because the one in the lead so far was 21 grams. Okay? 21 grams, 62 grams. This one is 3 times as heavy. Therefore, it should hold at least 12 bricks. Therefore, it's over-designed. Yes? Because the point is of this project is that we fail between 4 and 5 bricks. Fail at 4. 5 is enough. And so when you were designing this, if I can just ask a question, did you, in terms of the weight of it, why did you make it so heavy? You made a lighter one. Wow. Okay.
Thank you.
You're okay. Okay, can I get team 4 up here? Team 4.
Oh, sorry.
Okay, we got 4 bricks so far. We need 3 times that weight. If this is equally as efficient as Team 1's bridge, it will take 12 bricks.
No, it's their team. So their bridge held. They fell on the fourth bridge. Yeah, no. Those 3
Okay, we got 6 bridges, 6 bricks. Let's have a look at these tension. I'm feeling this, and I'm feeling. They're all pretty much equal tension.
Joe, are the ratios,
Sorry guys, can we just tone down the murmuring, please? Because I need to.
are the ratios the one where it fails at or the one that actually withstood? Because if it's not, if it's the one that fails at,
The ratio, by the way, these calculations are based on what it was holding just before, yeah, you put the final brick on to cause it to collapse. So it holds its own weight, it holds a certain amount of weight. And then the failure, the point of failure is always when you load it with that final brick, okay? Absolutely. Keep loading up.
because they failed at 4. Three times.
She is.
3 times 2.177. 6.5.
Are you going to take it?
Connor. Connor. How much did your push? Is your ratio 4 or 3? Is your ratio with 4 or 3? Corinna, I think you should move or else no one will get the phone.
Loaded on that side.
Keep going.
Okay, what do we have here? 9 bricks. It's really solid, eh?
Here the type.
Keep going. It's gonna have to hold 12 to take the lead. Although there's a weight, there's an efficiency here in terms of the over design. Okay? There's not that much torsion on it either, and that's probably because when you're hanging the brick, say, it's much better for a design like this than to load on top of the arch, because gravity's working with you. Of course. So it's holding the bridge from torsioning. 10 bricks. Okay. Keep going. Load, yeah. Keep going. Use a different, that's not the same brick, eh? Okay, that's 11 bricks. Okay, let's go for 12. Okay, 12 bricks, we'll put this in a tie. Again, let's do some maths here. This bridge weighs how much?
62 grams.
19, 62 grams. So far we got 12 bricks. How many bricks? What's the weight of that, please? 12 bricks times. Can someone tell me the number? 12 bricks is how many kilograms? 26.124.
What's the weight? 62.
Okay, so can someone do a strength to weight ratio, please? 62 grams is holding 26.124 grams. What's that? 13. Okay. We got 13 now.
421. Well, minus that was on 12.
What we got so far?
421, but that was on 12.
Francisco, how many does 13 bricks weigh?
I did it on 12, not 13.
Do it on 13. What?
28.301.
And what's the weight to strength ratio now?
437.
437, okay? 437, so far we're in the lead with this, but
13.
it's arguably the bigger thing he is, yeah, the more weight it's going to hold. There's a relationship between efficiency of the bulk of material to the weight and the less amount of material to the weight, if you understand what I mean. You have a very, very light bridge that can hold 4 bricks, but then you could put a concrete beam across here and hold a truck. Okay. So in other words, the game changes when you get a certain, in other words, the more mass you throw at something, it's exponentially more stronger. Does that make sense to all of you? Okay. What are we going to do now? You can't fit any more bricks in.
But the...
Cut some strings.
You're going to have to... No, start loading them on top. Put them on top of that arm. Yeah. No time to start flapping around with all that stuff. There you go. Yep. Okay. Is that 14 bricks? Hang on. There you go. Now I can put on top. Okay. Oh, what was that?
Oh, you're hearing something.
Yeah, I'll throw it. That's 15. Let's keep going. Why don't you turn that one flat? Yeah.
There's no snow.
It's 15. The next one. Oh, 16. There you go. That's 16 bricks. It says holding at 16. 17. 18. Now, 18 bricks. Start slacking off here, this middle.
Yeah, because we started building that.
Exactly. You start putting in compression, starting to slacken it, and when it's starting to slack, it's starting to lose its strength. Okay? So that's at 18 bricks. This is brick number 19. Lay towards the front. That's 19. Okay, hang on.
Gavin.
Gavin. "19 bricks. Will it hold 20? Further forward. 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 Yeah.
Is leaning that way now.
Yeah, that's it. Stop. Leave it. Leave it.
Is leaning to the table.
Put it. That's it. Okay, ladies and gentlemen, that's 20 bricks. Whisper is going to fall over. Okay, now hang on. I'll get some photographs laterally of this. Keep documenting it. I would take a photograph on the side. Those 20 bricks.